we're going to be taking a look right now as to how we can actually use sine law to solve for an angle or a side. Now, there are certain kind of caveats, areas that we may or may not be able to solve for. And so it's going to be important that we know if we can use sine law or not. So sometimes you can, sometimes we can't. And I'll explain in future lessons when we can and when we can't. For today, we'll just go over the examples where we can. Let's start with the first one here. If we know one side and two angles, we can definitely solve for sine law, or solve for another side using sine law. Okay, and again, I'm going to put sine law up here. It is sine A over little a is equal to sine B over little b, which is equal to sine C, which is equal to sine C over little c. And again, it all comes down to the way that we organize and make sure that we label our triangles properly. So if we know one side, so here I know the side 8.2, and I know two angles, I can find a second side. Okay, so in this case here, I can find side M. Now to do that, first thing we're going to do is we're going to label our triangle. Okay, so we're going to label this triangle, we're going to call it A. I'm going to usually use A, B, and C. We can use any set of letters, as was mentioned before, but I'll often use A, B, and C to label it. So we have little, and then we have little b over here, which is actually going to be M. That's okay. Little c and little a. All right. In this case here, we know little a and we know big A. And this is going to be very important that we know an angle and a side that are related. And so in this case here, we have big A and little a. That's very important that we have that to be able to use sine law. We know big B and we want to find little b. That's also good to know. So if we have the angle and we want to find the related side, that's really good. Sorry, I'm going to put that, there we go. Just correct that. Now, you'll notice here we don't have big C or little c, and that's okay. We don't need little c, so we're not going to actually use big C either in this case. To do this though, the first thing we're going to do now is we're going to set up our ratios. Okay, we have little a, big A, we have big B, we need to find little b, and we don't have C, so we don't really need to, but I'm going to write it out here. I'm going to write out my this equation here, and I'm going to plug in everything that I know. I'm going to write in sine law with everything that I know. So I have sine of 75 degrees over 8.2. And that's equal to B, so sine of 32 degrees over little b, which we don't know, and sine of big C over little c. Okay, so this is what we know from sine law. This is filling in our information from sine law. Now, these two are equal, so we can use cross multiply and divide to solve for little b. The thing is, okay, we don't need this one, so we're actually not even going to use it. We're only going to use these two right here. Okay, we're only going to use those two. We're not even going to use this one. We only need two of them. Okay, there are three because we could use all three, but we're actually only going to use two of them because we only need two of them. So in this case here, we want to cross multiply and divide. But when we cross multiply and divide, we always start on in the fraction that has one piece missing, and we start with the piece we know, not the piece we're missing. So in that case, it's sine 32. So we multiply across, in this case it's down, so up to down or down to up. Here we're going down, and then we divide by our third piece, and that's going to equal to b, or our missing piece. And what this looks like when we write it out, we're going to have sine of 32 degrees is equal to, or sorry, not equal, times 8.2, and then divided by sine of 75 degrees. And what does that equal? Then we need to figure out what that equals. And this is where the calculator comes in real handy. So we do sine of 32, and I need to close my brackets, make sure I close my brackets, multiply by 8.2, divide by sine of 75, And so I punched it in exactly like that. I hit equals and I got the wrong number. Huh. Now this happened by accident. I actually should not be getting negative 11. And how do I know it's wrong? Well, we can't get negatives. That just doesn't work. My calculator is in radians. Let's try this again when it's in degrees. So I'm going to do the same thing. Sine of 32 degrees times 8.2 divided by sine of 75 degrees, close brackets, equals, now I get 4.49, or actually 4.5 because we're rounding this up. So 49 becomes 50. So the answer is 4.5. We can say that m equals 4.5. Our value of m is equal to 4.5. Now, this is using sine law and the idea of common ratios, okay, to be able to solve. And when we have two common ratios, so two that are equal to each other, we can cross multiply and divide to solve for that. Now, like I showed here, we only needed a and b, but we could use any two. So we could use a, b, or c. Any one of these three, we're going to use two of them to find a missing piece. Now, of course, if you know two angles, then you can very easily find that third angle as well. So to solve for n right here, okay, and I'm gonna use different letters in this case here. So we're gonna plug in, let's use this here. So this is little n already, so I'm gonna make this big N. And then I'm gonna use ones that are very similar. So I'm gonna use big M, and this is little m, trying to cover it. And the third one I'm going to use is O and little o. Now, O's are really easy to see on a computer because we can really tell that one's bigger than the other. On your when you write it out or when I write it out, it's not necessarily always the easiest to see. But whatever the case, you can always make it work. All right, so let's take this right here and let's plug in what we know. So I'm going to do M, N, and then O. So we're going to start with making it a function. Sine of big M, which is 65 degrees, over 12. Okay, so we know that one. That's really good. And then we're going to use N. So we have sine of N over little n. And that is equal to sine of O, which is 40 degrees, over little o, 0. And we want to find little n. Here's the thing, we could find little o because we have one piece of information, but we can't find little n because we don't have big N. Okay? And that's really important. We need to make sure we have at least one piece of information from the ratio that we're trying to solve for. And we're trying to solve for little n here. We're not even worried about little o. We want to find little n. So we need to figure out what big N is. And that should be fairly straightforward, as was shown up here, is to find that third angle, we need to do 180 minus 65 degrees. I need to put my degree sign here. Minus 40 degrees. And that's going to equal that third one. And that third one is going to be, drum roll, any ideas? It's going to be 75 degrees. Okay. So when we subtract, we're just trying to find what that missing one is. So I can actually put that in here, and I'm going to write it in 75 degrees. Okay. So what that tells us then is that instead of doing n here, we can put in 75 degrees. And we can actually then solve for little n using cross multiply and divide. But we first had to find that third angle. And that third angle was the important part. Okay. We don't actually even need O at all because we have M and we're trying to find N, but we needed it to find that third angle. So let's draw it in here. Cross multiply and divide. And I'm going to use my little fish symbol here. Okay. Sometimes called the fish method because, well, it looks kind of like a fish. And so then we are going to plug that in here. So what does this look like here? Well, we're starting with sine of 75 degrees, and we're multiplying by 12, and then we're dividing by sine of 65 degrees, and that will give us our value of n. So this equals n. Now, if we use the calculator for that, again, make sure we're in degrees, sine of 75, close brackets, times 12, divided by sine of 65, close brackets, and I get a measurement of 12.78, or actually 12.79 if we round to two decimal places. Okay, 12.79. Now here's something that I want to go over really quickly here. Something that you'll notice is that, and I'm going to actually go up to the original one, this original page here, the bigger the angle, the bigger the side connected to it. So you'll notice here that in this triangle one, C is the biggest angle and side C is the biggest side. Angle A is the smallest angle and side A is the smallest side. Okay, so really important to notice that that's the case in all triangles. Okay, so you should notice here that n was the biggest angle, 75. So n better be bigger than 12. Okay, it better be bigger than 12. That's just something that we have to make sure that we see. Okay, and in fact it is. It's 12.79. The angle is slightly bigger. The side is slightly bigger. Okay, so very important that we recognize that. Now, if we know two sides and one angle that's not formed by these two sides, okay, so in other words here we need to make sure that we have a common angle and side, okay, very important that that is connected. We can then solve for that. Okay, so let's try this one here. So we have big A is right there. So I'm going to call this one little a. Because we're using A, I might as well use big B. And so then this is little b, meaning that I'm going to call this one then probably x, right? Now I'm going to call it little c. And big C. All right, so I'm going to use the B's and A's. Not going to worry about the C's. I've labeled it, but I don't really need them. Not really. So we have big A, sine of A over little a, which is 162, is equal to sine of big B, which is 47 degrees, over, where is that, 150, which is little b. And now I'm going to cross multiply and divide to solve for this. Okay, in this case here, I'm given the side. So here I need to start on the bottom. So when I'm cross multiplying and dividing, I'm starting on the bottom and then working my way up and around. And that's going to equal to my final answer. So we multiply first, we divide, and then we come up with our final answer. So what this looks like, and again, going to write it out as an equation here, 162 times sine of 47 degrees divided by, right, divided by 150 is equal to, well, let's plug it in. 162 times sine of, what did I say, 47, right? 47 degrees divided by 150. And I'm going to get 0.789. Well, that's not angle A. Okay, that's definitely not angle A. That is the ratio of angle A. And so I need to do inverse sine of my answer. Okay, and in my case, I have to answer. On your calculators, you might not have to. And I'm going to get that the angle is actually 52.17 degrees. Okay, and so our angle, so this is going to be, sorry, I'm just going to write this in here. This is angle A. And so our answer, let's just quickly get an angle in there again. Angle A is equal to 52.17, or, and again, if we round it, it's just going to be that angle A is 52 degrees. Okay. So that gives us that angle A is 52 degrees. All right, so that would be angle A. We could then find angle C, and then we could find little c if we really wanted to. But in this case here, we're just asked to find A. All right, finally here, okay, if we know two sides yeah, okay, sorry. If we know two sides and one angle not formed by these two sides, just like we did on the previous one, but we are trying to find the missing angle, okay? So in this case here, I'm going to try to use the same letters. And I'm actually going to tweak this a little bit because I did it, I'm going to call it wrong. I'm going to call this big C again. We're using actually the exact same one. So I'm going to call that big C. I'm going to stroke off that this is B. Okay, so I know in your notes it says B, but I'm going to make this into C instead. There we go. I know the magic of work, right? Okay, so this is big B then, and this is big A. And as we did before, this is little c, this is little b, and this is little a. Okay, and I'm doing this because I want to go through this a little quicker. I don't want to have to use all of sine law to find the angle. What we did, we used this exact triangle up here, and we found that angle A was 52 degrees. Okay, if we want to now find angle C, okay, we don't actually have to know side C. We just know that if we know these two sides, so we know, and this is based on our previous example, that angle A is equal to 52 degrees. Okay, and this is based on prior example. Okay, so we know that. We don't actually even have to solve for it again because we've already shown that. To find angle C, so angle C is equal to 180 degrees minus our other two. So 52 degrees minus 47 degrees, and that's going to equal our angle C. And so if we do the calculations, angle C is equal to 81 degrees. And so angle C is equal to 81 degrees. Now that we know angle C, we could actually find side C as well. Okay. Now, these are the cases where sine law works. We're going to get into cases where it doesn't work a little later on. So the only case that wouldn't work is if in our sine law we have one piece of each ratio. We don't have two. We always need to have two of one ratio. Okay, so we have to have a completed ratio, and then we can solve for really any other pieces, and we can kind of work through our process to find any other piece. Okay.